Good morning students, this is Dr. Ilangu, Professor, Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. In today's class, I would like to explain to you that how star system is transformed into delta connected systems and how delta connected system converted into star connected systems. In my today's presentation, I would like to explain to you that what is star connected systems, what is delta connected system, how star connected system is transformed into delta, similarly how delta connected system transformed into star connected systems. Finally, I would like to give the summary. Yes, first star connected systems. Actually, in three-phase electrical circuits, we all know that it consists of three number of windings like R phase, Y phase and B phases, right? So when we go for three-phase systems, the systems are to be connected in two manner. One is star connected systems and another one is delta connected systems. First, I would like to give the explanations for star connected systems. See, this is the circuit arrangement for star connected systems. See, from the representation, from the diagram itself, we can easily understand that the system is called as star connected systems, right? Now I will explain to you that how it is connected. Here, for each and every winding, each and every phases, it consists of two number of windings, two number of terminals. One is starting terminal and another one is ending terminal. How these are going to be utilized for making the connection, based on that it is classified under star connected systems and another one is delta connected systems. Here the similar ends up, whether it may be a start terminal or ending terminal, are connected to a common point, and remaining three terminals are connected to free terminals, are connected as the free terminals. From that we are going to retrieve the electrical power. See here, from this diagram easily we understand that it consists of three number of windings, R phase, Y phase and B phases. For all the three phases, it has three number of windings like A1, A2 is starting and ending winding. Similarly, B1, B2 is the second winding. B1 is the starting winding, B2 is the ending winding, and the third one C1, C2, C1 is the starting and C2 is the ending. Here all the three ending terminals are connected near common point. It is connected like this, and starting terminal are just connected to live parts like any electrical source we can connect it. Suppose if from the electrical source we are getting means, it will be connected as the load, right? This arrangement is called as star connected systems, right? Once we go for star connected systems or delta connected systems, we all know that there are two representations for both voltage and current. One is line current and another one is phase current. And for voltages, one is phase voltage and another one is line voltages. You may ask the question, what is line current and what is the phase current? What is the difference in between these two? Here, the current flowing through each phase is called as phase current. That is the current which flows through phase to neutral, it is called as phase current. That is phase current. And line current means the current flowing through each line conductor like R phase, Y phase, B phase are called as line current. And voltage across each phase, that is R phase to neutral, what is the voltages? This gives the value of phase voltages. And for line voltage across any two lines, R to Y, Y to B or B to R, it gives the representations for line voltages, right? See, from this diagram, I suffix NR is the current which flows from neutral to R phase, and INY, it is the current which flows from neutral to Y, right? So this is flowing through the phases, that's why it is called as phase current, right? Then I suffix R is the current flowing through R phase, IY is the again IY is the line current, IB is the line current. When we go for voltages, E suffix NR, that is the voltage across R phase alone, right? The voltage across R to neutral, right? And ENY is the voltage across neutral to Y. ENB is the voltage across neutral to B. It gives the representations phase voltages. And line voltage, we know that the voltage across two lines, R to Y or Y to B or B to R, that represents this voltage, that represents this line voltages, right? When we look at these star connected systems, here we easily understand that line current is just equal to that of phase current, because there is no any any branches in between ENR and IR. Similarly, INR and IR, there is no any branches. Similarly, INY and IY, there is no any branches. The same current which flows through the winding as well as the phase terminal like R phase, Y phase and B phases. So there is no any differences in between line current and line voltages. Line current is just equal to that of phase current. But when we have to consider the voltages for this star representations, line voltage is equal to √3 times of the phase voltages, right? See, this is the representations for star connected systems. When we go for delta connected systems, here the start terminal of one winding is just connected to finish or ending terminal of the other winding. Here it is also there are three number of windings like A winding, B winding and C winding. Each winding has two terminals like A1, A2. A1 is the starting winding of coil A. A2 is the ending winding ending terminal of the coil A. Here A2 is just connected starting winding of the B coil, and B2 is the finished terminal of B coil just connected with that of C coil starting terminal, right? See, if you had to connect three number of windings in the three phase systems like this, the system, the representations are called as delta connected network. Here it is also the same explanations for line current, line voltages, phase current and phase voltages. When we had to equating line voltage, phase voltages, line current and phase current, we came to know that line current is equal to √3 times of phase current and line voltage is equal to phase voltage, right? See, this is the representations for star connected systems and delta connected systems. Now I would like to explain to you that how we had to transforms, how we had to convert star to delta and delta to star. See, this diagram gives the representations for both delta connected systems and star connected systems, where the terminal small letter A, B, C represents the three number of terminals for the three phase circuits, right? When we had to consider the delta connected systems, the resistances across the two phases A and C represents RAC, and B to C represents R suffix BC, and A to B represents R suffix AB. Similarly, for star connected systems, there are three terminals A, B and C. Through the phase A, the resistance is R8, RB is the resistances of the B phase, RC is the resistances of the C phases. Now I would like to give the explanations how we are going to transform. For that cases, just we are calculating resistance across the terminal A and C in delta connected systems. What is delta connected systems? That is left hand side diagram shows the delta connected systems. So A and C across this, what is this? There are three resistances are connected. That is resistor RAC is just connected in parallel with that of RBC and RAB, right? So the resistance across the terminal A and C in delta connected system gives that representation RAC just parallel with that of RBC plus RAB, and we know that how the two resistors are connected, right? How the two resistors are connected in parallel, we know the equivalent resistance formula, that is RBC RAC into the product RBC plus RAB by RAC plus RBC plus RAB. That gives that representation for that cases. That is resistance across the terminal A and C in delta connected system. RAC is just connected in parallel with that of RBC plus RAB. So from that combination we obtain the equation RAC into the product of series resistors RBC plus RAB by the total resistance, total RAB RBC plus RAC. This is RAC RBC plus RAB. This is the representation of delta connected system alone. Okay. Then from these cases, when we are going to cross multiplying that RAC with that of RBC plus RAC, we got a equation RAC RBC plus RAC into RAB divided by the same denominator. We got the value, all the three resistances RAC RBC plus RAB. This is the representations for delta connected systems. When we had to consider these star connected systems, the same resistance across the terminal A and C in star connected systems. What is this? A is bottom and C is upper, the upper phases. In between these two, what is this? Only the resistance RA, RC come to the picture, where RB is not connected. RB resistor is not connected, only we are obtaining the equivalent resistance in between the terminal A and C. So that gives the value RA plus RC alone, right? So for these cases, when we are equating these two for delta connected representations and star connected representations, we got a equation number 1, that is for star connected representation RA plus RC. Just now I told you that, and in left hand side, sorry, right hand side, delta connected system representation is the RAC RBC plus RAC into RAB by the total resistors RAC plus RBC plus RAB. So this is the equation, this is the equivalence of resistances in between the terminal A and C. Similarly, we had to obtain the equation for A and B. See, previously we obtained the equation for A and C. Now the resistance across the terminal A and B, we got a equation number 2, that is RA plus RB is the star equivalent cases, and right hand side gives the value RAB RBC plus RAB into RAC by the total resistor RAC plus RBC plus RAB. This is the equivalent resistance in star connected and delta connected systems in between the terminal A and B. And for third cases B and C, what is the equivalent resistance between the terminal B and C? For star connected systems RB plus RC, because RA is not going to connect it, and for this delta connected systems RBC RAB, RBC into RAC by RAC plus RBC plus RAB. This is equation number 3, right? So from that cases, star and delta connected systems, when we had to consider the resistances in between the terminal A and C, A and B and B and C, we got 3 number of equations, 1, 2 and 3. For these cases, right hand left hand side gives the value of equivalent resistance across the terminal like AC, AB, BC in star connected systems, and right hand side represents these delta connected systems. In that delta connected systems, denominator values are common, only the difference is numerator. Numerator only we have a differences as per the derivation. Right, here just we are going to adding equation number 1, 2 and 3, we got a value here. When we are to adding equation number 1, 2, 3, what is this? Right hand side we got 2 number of RA, 2 number of RB and 2 number of RC. So 2 times RA plus RB plus RC come into the picture of left hand side, whereas in right hand side it's also RAB RBC term, there are 2 times, and RBC RAC term will be available for 2 times, and RAB RAC is also available as a 2 number of terms. So we had to get the equation like this: 2 times of RAB into RBC plus RBC into RAC plus RAB into RAC divided by the same denominator we are obtaining, right? And from that cases, left hand side and right hand side, the numerator 2 will be cancelled each other, and we got a equation number 4, that is summation of star connected systems RA plus RB plus RC, that is equal to the product RAB RBC, RBC RAC and RAB RAC. There are 3 number of combinations, and a denominator we have a same value RAB RBC and RCAC. This is equation number 4, right? See, from the first 4 equations, just we are going to obtain the delta to star transformations. From the first 4 equation, just we are subtracting equation 1, 2 and 3 from equation number 4, right? From equation number 4 we obtain. See, equation number 4, left hand side we are having the resistances RA plus RB plus RC. When we are subtracting from the equation number 1, RA RC cancelled, only RB term come, right? Only RB term come to the picture. Similarly, when we are subtracting 2 from the 4th equation, RC term come into the picture, and when we are subtracting the 4th equation from 3rd equation, what is this? RA, RB, RC term is there in 3rd equation, so RA come into the picture. So RA is equal to, we got a 3 number of equations representing RA, RB, RC, that is RA is equal to RAB into RAC by denominator RAB, RBC, RAC. The same denominator will be obtained for all the three equations. Only the difference is numerator. So this is the equation for delta to star transformations, where R suffix A is the star connected systems resistances. RA, here when we had to consider RA, see, just we had to consider the star connected system is inside of this delta connected systems. RA is just aligned with that of RAC resistance and RAB resistances of delta connected systems. So this is the product in the numerator, RAB into RAC. Denominator, all the three resistors, all the three delta connected resistors is RAB, RBC plus RAC. Similarly, RB, when we have to consider RB, the nearby resistances of these delta connected systems are RAB and RBC. So from that derivation we obtained RAB into RBC by the total resistance RAB plus RBC plus RAC. Similarly, we had to derive the expression for RC, that is equal to the combination RBC into RAC divided by RAB plus RBC plus RAC. So this is the representation equation for delta to star transformation. This is the way we are going to transfer it. Similarly, when we have to consider the delta to star to delta transformations, for that just we had to get the equation 5, 6, 7. This is nothing but delta to star equivalent resistances. From that equation we obtain star to delta transformation. Here just we are doing the equation 5 into 6, just we are multiplying the equation 5 and 6 and 6 and 7 and 7 and 5, and we are adding all the three combinations. So equation 5 into 6 plus 6 into 7 plus 7 into 5, that becomes the value RARB plus RBRC plus RCRA in left hand side. Just you consider the left hand side, equation 5 is RA, when we are multiplying with the sixth equation. So in left hand side RA-RB combination come to the picture, and 6, 7 multiplying means RB-RC, and 7 and 5 multiplying means RC and RA. This is the left hand side representations. And for right hand side representations, that RAB term, RAB will be available for square times RAB squared RAC RBC plus RAB RAC squared RBC plus RAB RAC into RBC square. For each and every term, RBC, RAB and RAC will be available in square times. So we got an equation like this. From that equation we can simplify it into like this, that is RAB, RBAC, RBC had to be separated out in right hand side. We got an equation like this. At denominator it's a square term available, and from that equation numerator RAB, RAC, RBC only available. The combination RAB plus RAC plus RBC will be cancelled from that of denominator square term, right? So in denominator we got only one term like RAB, RBC plus RAC. So this is equation number 8, RA-RB plus RB-RC plus RC-RA. It gives the value RAB, RAC, RBC by RAB plus RBC plus RAC. This is equation number 8, right? From that equations 5, 6, 7, 8 easily we can convert star connected systems into delta connected systems, right? When we are dividing the equation 8 by 5, when we are dividing the equation 8 by 5, what is this? RA-RB plus RB-RC plus RC-RA divided by RA, right? Left hand side we obtain the equation RA-RB, RB-RC, RC-RA divided by RA. In right hand side we got only the term RBC, because the remaining term will be vanished with that of denominator of this equation number 5, right? So we got a equation for RBC, that is equal to RA-RB plus RB-RC plus RC-RA divided by RA. Similarly, RAC is equal to RA-RB plus RB-RC plus RC-RA by RB, and RAB is equal to RA-RB, RB-RC plus RC-RA by RC. How to remember, how to memorize this? See, very easily we are going to memorize this star to delta transformations also. See, when we have to determine the RBC, that is the resistances in between the cases, what is this? Numerator is common, that is RA-RB, the product RA-RB, RB-RC, RC-RA. The denominator, there is no part of this R branches. B and C, so only A term will only be there. So from the way we are going to easily memorize this star to delta transformation equations and delta to star transformation equations. Thank you.